Sir, mic is off.
Yeah, thank you. Yeah, for this session, I'm going to take you two different topics. The first one is ANCOVA, and if time permits, I'm going to proceed with a test called Manova. So as you can see on the screen that I've written two different terms. The first one is ANOVA and second one is ANCOVA. Difference we have discussed earlier, but still I'll let you know. ANOVA we have already did, and you can find that there is a difference of this C, which makes a test different. And ANOVA stands for analysis of variance, whereas ANCOVA stands for analysis of covariance. So in this section, we will learn how to run the ANOVA, especially in two-way. So one-way ANOVA we have already studied, and two-way ANOVA means there are two independent variables. There are two independent variables. That the difference in one-way ANOVA we have only one independent variable, and that independent variable will be called as categorical. So when that particular independent variable will become numeric, then the test will be called ANCOVA. What it means, whenever independent variable is categorical, then the test will be called ANOVA. And when independent variable we are taking as a number, numeric, the test will be called ANCOVA. That's the difference. So what we have a if you want to run a ANCOVA, we have a more than one independent variable. That means number of variables will be more. These are the requirements. So most of the requirements for the ANOVA and ANCOVA remains similar. There is a difference in the type of independent variable. That means dependent variable should be numeric in both the cases. I'm talking about ANOVA and ANCOVA. Everything will be remain same instead of independent variable. Distribution of dependent variable should be normal. That means we have to apply the test for the normality distribution to the dependent variable, and we should have got a bell-shaped curve. Variance are homogeneous. That means test for homogeneity, which we are going to get. The p-value should be more than 0.05, and we have to prove that equal variance has been obtained between all the categories. If categorical variable we are using, for example, if three categories are there, A, B, and C, so we have to make sure that in each category, number of the participant should be this much that they are eligible to define something. You can't say that in one category we have 50, in second category we have 40, and in third category we have only 10, if you're talking about total of 100. So that should be uniform. Might be there is a difference will be acceptable, but not that much. So for this analysis, I'm going to use a dataset 2.6. It is the same which I have used for the linear regression through GLM, where we have compared physical activity with calorie intake, and dependent variable was BMI, sorry, systolic blood pressure. So the same dataset I'm going to use. So if independent variable is numeric, then the test will be called as ANCOVA. This we have already discussed. So that stands for analysis of covariance. So this is the test which we are going to proceed. And in the last two slides, I have discussed that what was the difference between ANOVA and ANCOVA. So analysis of covariance, this we are going to study, is quite similar to ANOVA only. But as I have already discussed that we are bothered about independent variable, and if independent variable given in terms of numbers, numerical order, so test is going to be changed, that falls under the GLM. So in dataset 2.6, which I have used, everything remains same, but I'm going to add a covariate in it. Covariate means age I'm going to add as a covariate. Now we can see we can run the GLM through ANCOVA. So I'll let you know that what was there in the test. These are the steps which we are going to use in SPSS to apply the test called ANCOVA. So you can see this the same data set I'm going to use, which I have used in the previous model, like linear regression through GLM. That means we have age, we have a calorie intake, we have a physical activity, and we have a systolic blood pressure as a dependent variable. So this will be called as dependent variable systolic blood pressure. Now you can see that calorie intake is given in term of category, where two category was there, below RDA and above RDA, and physical activity also we're having a three category called mild, moderate, and high physical activity. Now you can see age has been added as a cofactor. That's why because of this age, the test has come ANCOVA. When I'm not going to add age as a covariate, then the test will remain as a linear regression using GLM. So I'll let you know that how to proceed. These are the steps, so I'll not read it out. I'll just show you in the SPSS slide that how to apply the test. As you can see on the univariate model. So what we have to do, we have to go to first analyze, then go to GLM, general linear model, and under the general linear model, we are going to find a option called univariate. So univariate is the command for the ANCOVA, and as you can see that systolic blood pressure has been added on the top. This is the dependent variable, systolic blood pressure, and these are the independent variable, calorie intake and physical activity in terms of category. And here I have added a covariate, which is a numeric variable, age. So all three has been added, and you can see that
I found this on the web.
As you can see that now I'm going to customize the model. So for that I have to click on the model. So for that, if I click on the model, I'm going to get a model window. So I have to click on custom first. So when I click on custom, these things, all the independent variable will appear. So the same like previous time, here we have to find out that importance, that to which variable we have to give more importance, that variable we have to switch into a left side window. So already calorie intake and physical activity has been added, so I have added a age also by this icon. And this is the icon which you can use to move variable from this side to this side or this side to this side. But make sure that here, from instead of interaction, you should convert this one into a main effect. So whenever you'll open the univariate model, you are going to get this type, build term type, as a interaction. So you have to change this one into a main effect. So you can click continue. Once you will move all the three variables from this side to this side, you can click continue, and here you can see, then after that you have to click on the option. These are the option window, and by clicking on option you can find that which tables you require. You can click on descriptive statistics, you can click on estimates, you can click on power observed, you can click on parameter estimate and test for homogeneity, and you can check that what was the confidence interval of the study, either it is 0.05 or not. So the same table you are going to get which you have got in the linear regression through GLM. So first table was what? First table is the same which we have got in linear regression through GLM. As you can see that in this table we have got the status of calorie intake and status of the physical activity, how many patients were falling under what category, and the software is going to remind the codes, that code 0 is used for below RDA, 1 is used for above RDA, and under the physical activity, code 0 is used as a low, code 1 is used as a moderate, and code 2 has been used as a high, and how many number of patients were fall under each category. Total sample size is the same which I have kept in the last test. It was 75, number of 75 patients. So first table is going what? It is just giving a, is reminding the code, and it will let you know that how many categories are there, under each independent variable, and how many patient or number were falling under what category. Second table is the descriptive statistics, and as I discussed earlier, we don't have to see the totals, and we have to see is if the model is 3 by 6, so we have to 3 by 2, so we have to find the 6 reading. So what we will do, we will not see this total we are going to ignore. The total of this also we are not going to see, and the total of above RDA I'm not going to watch. So out of these three, and out of these three, top three and bottom three, I have to find out that what was the minimum, mean BMI, and what was the maximum, this systolic blood pressure in mmHg. So we can find that minimum value is 113, I think. 113, sorry, 1112. This is the minimum. This value, I'll just delete all the things so that you are able to see. This is the minimum value out of those 6, and the maximum was found to be 149. So these we can quote in the research paper or the review paper, that patient having physical activity status as high, and they are taking low calorie intake, their blood pressure is going to be reduced, or it will be found minimum. So here patient is going to be benefited when the number of systolic blood pressure should be on the lower side, whereas highest blood pressure was found among 19 patients. You can quote the number, having a systolic blood pressure of 149.26. Those who were doing low physical activity but taking the diet above as recommended by the physician. Clear? So this is the descriptive statistics, and for research point of view, you are going to take the mean, SD, and N from this table. So, and even you can quote these two values, minimum and maximum, while writing the descriptive statistics. The third table is test for homogeneity, Leibniz test, which shows what? It shows that equal variance was maintained between these or not. And you can see that for all the 5 category, we don't have to bother. We have to see under each independent variable that equal variance was maintained or not. And you can see here the number of difference of the both patient is 5. In one category, in below RDA we have 35, and above RDA we have 40. So difference of both patient was found 5, so not that much. But here you can see in one category, low we have got 26, moderate we have got 31, and high we have got 18. There is a little bit of difference between these two categories, near about 17 or 18. So this two variable are not going to affect the test for homogeneity. For example, if instead of 18, if only 2 patients are there, only 3 patients are there, then we are going to get a low p-value in case of test for Leibniz or test for homogeneity. But this number of patients which are given under the category of high, 18, are sufficient to conclude something. So software, what they did, the p-value was found. See, it's 0.58, more than 0.05. So whenever we are taking the reading of especially 3 statistical tests, as we have discussed earlier, test for normality distribution, test for Leibniz, and test for homogeneity, there we are taking p-value more than 0.05 as a standard. So here we can see that our value was found more than 0.05. So we can say that equality was maintained between all the 3 steps. Otherwise, you are going to stop here. You are not going to proceed with the test. As we can see that now equality has been maintained, we can see the further results. Now, here we are going to find the difference between the linear regression through GLM and the ANCOVA. In last test, what we have found, all the three table which I have discussed till now was the similar which we have got in the linear regression through GLM. But here you can see one more variable has been added, that is the age. This is our physical activity and the calorie intake, and new variable has been added, age. Now age is going to affect or not. So what we have to do, we have to see these three p values, and by seeing these three p value, we can find out that which independent variable is going to affect the systolic blood pressure or not. Now aim of the test of what is like a similar which we have studied in the linear regression through GLM, that we want to find out the factors which are affecting the systolic blood pressure. So here you can see we can prove that calorie intake is going to affect the systolic blood pressure. Physical activity is also going to affect the systolic blood pressure, but the p-value of age was found more than 0.05. So we can say that age is not going to affect the systolic blood pressure. This because of this reading, it's more than 0.05. If this value was found less than 0.05, we can say yeah, age is also affecting. But here we have proven that out of three independent variable, calorie intake, physical activity and age, two are going to affect, but one is not going to affect the systolic blood pressure because of this reading, because it's more than 0.05. Actually now it's a your decision. Now whatever the value we have got here, if I'm going to consider the third digit after decimal, so it's showing that more than 0.05. If I'll ignore the third digit, now I can say it is equal to 0.05. So it's up to me that how I want to represent the result. I can represent if I represent my result after two decimal only, I will say yes, age is also going to affect. But out of these three, which one is going to affect more? So what we have to do, we have to see the lowest p-value. Lowest p-value was obtained under calorie. So what we can say that calorie is going to affect more as compared to physical activity and age. So any independent variable which is having a low p-value, that is going to affect more as compared to others. So that you can find out by comparing these three p-values, which I'm going to add in the circle, these three p-values. Clear? Next table, parameter estimates. This we have already discussed. So here you can see nothing new. The same data we have got, that last category of each independent variable will become standard. Like one here become as a standard, and here two, that is high physical activity, become as a standard, and we have not obtained any data. And we can find out that if person are doing high physical activity and they will switch to moderate, so how much blood pressure is going to increase? 13.90 mmHg. And from high, if they will switch to low, how much systolic blood pressure is going to increase? It is 25.96 mmHg. And if you're taking a diet recommended by the physician above, and you switch to normal diet which is recommended by the physician, your mean systolic blood pressure is going to reduce minus 70. So this, it will be quoted by the beta. So beta is very important in this table. So age, we don't have any category, so we cannot compare. Because if, for example, if you have taken a data of age like 10 to 20, 20 to 30, 21 to 30, and 31 to 40, then you can compare that last category. For example, last category is this one, 31 to 40, then this will be compared with these two. But that test will not be longer as ANOVA. For ANCOVA. For ANCOVA, what we need a one independent variable as a numeric. So here just you can quote the reading that the beta of age was found to be minus 0.70. Clear? this is the output sheet that how to write we are going to write the results. So you can write that Leibniz test again shows that assumption for equal variance was obtained, still p-value was found more than 0.05, and ANCOVA shows that age is not associated with systolic blood pressure. Now why I have considered that not associated with blood pressure? Because of this 8, because I need this value less than 0.05, whereas calorie intake and physical activity is going to affect the systolic blood pressure, and they are found statistically significant. And you can write that age was found not statistically significant. So this was a test. So there is not that much difference. For example, if you have done the practice of linear regression through GLM, then you can find that if you're going to add one more variable as a covariate under this option here, under this option, this one where covariate has been written, so the test is going to change. It will become the ANCOVA. That means, and I'll let you know that how much is the difference, that how covariate is going to change the number of p-values. In this in ANCOVA, we have you can see that we have found p-value 0.02 and 0.05. This much low p-value we have got. Clear? And when we have run the same test with the same population, that time we have got the another p-values. Now p-value, you can see how much it is for calorie intake and physical activity. It is 0.004 and 0.027. Please. So that this is the difference, that by adding a covariate, the data is going to switch. It is going to take that how much is the age of the person who were taking high calorie, or how much is the age of the patient who were taking a diet recommended by above, and what was the age of the patient who were going into a category of high physical activity or low physical activity or moderate physical activity. According to that, it is going to compute. So you cannot say that both tests are similar. By adding one covariate as a factor is going to change your results. So this is your ANCOVA, and if any person is having a doubt on ANCOVA, then I'll happy to take the queries. Otherwise, I'll start another test called Manova. I'll just see the chat box. If any person is having a query in the ANCOVA, please let me know. So I will be happy to clear. Otherwise, I'll proceed to next test called Manova. Or we can take at the end, you can write it down, query at the chat box. So when I'll finish with the session, that time I'll answer all the queries. So we'll go to another test called Manova and MANCOVA, which are more advanced. Now, what we are going to do, we are going to add a more number of variable. And example I have taken, as I have done in my PhD, that I'm going to compare the same variable which I've shown in the research paper, the length of stay and the cost. But little bit difference I have made. I was working on diabetes and hypertensive patient. Here I have added a example of bones. For example, the type of treatment given for the fractures. So the main factor under this study is the type of bone graft used. For example, there is a clinic, and in that clinic, multiple type of treatment will be given for the treatment of fractures. For example, doctors used to do the surgery. So during the surgery, they have multiple options. For example, they can use a biomaterial. They can use the bone substitute, that will be called as bone grafting, and they can use a autograft. So treatment of the fracture was done by 3 different types. That means one type is your autograft, second type is your bone substitute, and third type is the biomaterial. By using any sort of biomaterial, the fracture is going to be healed with the help of surgery. So that doctor, a group of doctors want to find out that which type of treatment, either autograft, either bone substitute, or either biomaterial, is effective more, by comparing cost of the treatment and by comparing the length of stay in the hospital after the surgery. For example, if you're going to use autograft, might be patient have to stay 6 days in the hospital. If you're using bone graft, then 7 days. And if you're using a biomaterial, then 8 days. So you're comparing these days, that type of material used to treat the fracture, by comparing length of stay and cost. Now, one more co-factor I have added, because age is also a very big factor. Because if you are at the younger age, the bone is going to heal earlier. And if you are geriatric patients, then obviously after 45 or after 50, the bone healing is not that much. So age is also going to contribute in the treatment. And for example, if you are 18-year-old, then obviously it is going to be healed earlier as compared to the elderly patients. So age will become as a main factor in the test. Along with that, we cannot say that all bones are similar. You are going to get a patients of the multiple type of fractures. You are going to get a fracture of femur, fracture of tibia, and if any person who is suffering from fracture of femur, it is going to take around 3 months or 4 months to recover, instead of fracture of any other bone, because femur is the largest bone in our body. So fracture of tibia will take another near about 2 months, whereas the femur will take near about 5 to 6 months, something like that. Clear? So type of bone where fracture has been occurred, that is also going to affect. So we have a multiple variable. Now, what are those variable in the test? And this overall situation will be called as a model. And from this particular model, you can come out with a one research paper. Now, we'll discuss that what model contains. Model contains type of treatment given. This is the one type of variable. Independent variable will come your type of treatment, the type of material used for the treatment. Second independent variable will become your age. Third independent variable will become type of bone, whereas dependent variable which we want to find out that what is the cost and what is the length of stay. So these two will become the dependent variable, which is given in form of number. But independent variable age is given in terms of number, type of treatment given is category, and where fracture has been occurred, in which bone, that is also given in terms of category. So we have a two categorical variable under independent and one independent variable which is numeric. So three independent variable we are running together. Out of three, two is category and one is numeric. Clear? And with two dependent variable which is given in form of number only, that two categorical variable are given in terms of number. Which one are those? Cost and length of stay. So this is called as a model. So whenever you are doing a PhD or you are doing a master research, as I told you, in PhD we should have more than 10 or 15 different models. And if you're doing a master thesis should at least have a 5 or 6 different models. And if you want to give a small project to one of your students, those who are in undergraduate or those who are working in a lower classes, you can give only one model. Then try to find out this, that what is the cost, what is the length of stay. Don't give that, go and find out the prescribing pattern of anti-diabetic drug, or try to find out the prescribing pattern of antihypertensive drug, which are now most common. Try to give a small project like this one, where you can come out with something, and finally you're going to end up with a research publication, because it's a small project which will be done by a undergraduate student also. Only one model that you are going to compare the cost and length of stay by comparing the three different type of material given for the treatment of fractures by taking age as a covariate. So I will see how to proceed, and this is the data set how we have made. All the 5 variables has been entered, and you can see on the screen that cost is numeric, length of stay is numeric, which is both are dependent variable. Here age is independent variable, which is given in terms of number, whereas these two, site of fracture, where fracture has been occurred, and type of treatment given is category. Now you can see how many categories are there. We have 0, we have 1, and we have 2. That means type of graft use was 3 categories, which we have discussed in the last slide: autograft, bone substitute, and biomaterial. And site of fracture, I have taken only 2, 0 and 1. Where fracture has been occurred, I have taken only, for example, tibia and femur, 2 type of bones. Clear? So like this you are going to fill the sheet. And what was the that for now we can see that how data has been entered. For example, patient number 5, we are going to check the data of patient number 5. We are going to see this is the patient number 5. Patient number 5 was have spent near about 965 USD or INR, whatever. He has spent this much cost for the treatment. He spent around 8.5 days in the hospital. Age is 27. Type of fracture where fracture has occurred was 1. That means 1, we will find out that code 1 belongs to what. And type of treatment given was bone substitute. That was the code number 2. So like this you have to identify individual patients. So 5 columns will be made to apply the test. Now we'll see these are the steps which we have to follow for a test called Manova. And I will let you know that what was the difference between these Manova and MANCOVA in the further. That means we have to add one more variable and test will become the MANCOVA. We can go to the same option, analyze, go to GLM, and under the GLM, instead of univariate, now you're going to multivariate. Now how I used to remember that which command I have to apply. Multivariate of M of multivariate, I'm going to match with the MANCOVA and Manova. And U, I'm going to attach always with the A, ANOVA and ANCOVA, U of univariate, which you are going to see here. That means if you are here univariate, that means you are applying ANCOVA or linear regression through GLM. Clear? And if you are in multivariate, you are going to multivariate, it means you are going for these 2 tests, Manova and MANCOVA. So as you click on multivariate, you are going to all these things steps we have to follow. I'll let you know that what are those by help of these pictures. You can see on this side that I have added all the variables. Cost we have, length of stay, age, site of fracture, type of graft. Now both dependent variable has been added, which is cost and length of stay on the top. Fixed factor will be categorical variable, that is site of fracture and type of graft use was the fixed factor. So there it has been added. I will not add age. So test is Manova. If I'll add age as a covariate, test will be called MANCOVA. Whenever you are using a covariate, then test will be called ANCOVA. And if we are going to run two dependent variable and two categorical variable, and when we don't want to add age as a covariate, then the test will be called Manova. That's the difference. So in first test, I have not added the age, and remaining things all will be like univariate, which we have did, that we have to customize the model, and we have to see that all site of fracture and graft will be taken as a main effect, and after that you have to go to contrast. This option we have not seen in the previous test, option called contrast. In contrast, it means what? The which factor you are taking as a priority. That means site of fracture is the main variable in your study, or the type of material, which one. So you can click on that, you can choose that graft. I want to find out that graft will remain the main variable in my study, and what you have to do, you have to click on that one, that graft is the main, and you have to click on these two options called simple. There different terms will be there, like deviation, simple, difference, Helmert. So you have to click on the simple and click on first, that result of graph I want first. If you choose these options, you can click continue, and you are going to, and after that you have to go to option, and option you have to click on those options which we have already seen in case of ANCOVA, or in case of the linear regression through GLM, that we need a descriptive statistics, we need estimates, we need observed power, we need parameter estimate, and test of homogeneity also we want to find out, and you can check confidence interval of the study, and you are going to get a results. So studying the type of results is similar, which we have seen in case of the ANCOVA or in GLM. The first table which we are going to find out is the coding, as well as the number of patients following under what category. And you can see in first table what I have got. In first table we have got the site of fractures. That means we have three category: humerus. When I have shown the screen to you, this one, so that time on the screen only one site was visible, only one, only two code was visible. But when you'll go down side of the sheet, might be code number 2 also has been used. So that's why it is showing that three category are there under site of fracture. So three category are there under site of fracture, and three category are there under type of treatment used. So what are those category? So by seeing the half sheet, we cannot recognize that how many category are there. So this table is used to find out that how many category we have made for site of fracture and type of graft use. So both are having a 3 category. That type of humerus code 0, type of tibia code 1, type of fracture in the femur code 2. Because only 7 participants were having a code 2, so we are not able to see on this column. It will be at the bottom, because it's a data of around 75 patients, so you are going to see only 18. So after 18, the code 2 has been used in this column, so we are not able to see. Might be at the bottom it will be having. So how to find out the results? As you can see, the first table is going to let you know the codes which you have used and how many patients are there in the study. So total of these three will be the sample size of your study. 39 plus 34 plus 7 will be equivalent to these three. Okay, so you can see that humerus fracture occurred to 39, fracture of tibia occurred to 34 patient, and fracture of femur occurred to 7 patient. And type of biomaterial used, The autograph was used in 29 patients. Biomaterial, including platelets. This is the type of treatment. Biomaterial, including platelets, was used in 27 patients. And biomaterial only used in 24 patients. So you can see that variance has been somehow equivalent. All the patients were having a difference of only 4 or 5, something like between all the three groups. But here you can find that two category are having, one category is having a 39 patient, second one is having a 34 patient, and only 7 patients are suffering from the fracture of femur. So that's why in this case we need a results of the test for homogeneity of the variance. If test passes, that means these 7 patients are sufficient to conclude something. It is not going to affect the test results. That number 7 are sufficient to conclude something. If test fails, we are getting a Leibniz value or test for homogeneity value less than 0.05. It means 7 patients are not sufficient for comparison. So in that case, what we have to do, we have to include more number of patients having a fracture of femur unless this test. I have not added here. I have not added that test for Leibniz, which we are going to see in the previous class. This one, test for Leibniz value. It should be more than 0.05. You are going to get a table for this one. And might be I will forget to click on the test for homogeneity when I have applied the test. I have clicked, you can see I have clicked on this one. I should have got the table, but on the presentation I have not added, but you should refer that. If the value of test for homogeneity is more than 0.05, then you can proceed with the results. Otherwise, just you can give the descriptive statistics, that how many patients were falling under what category and what was the mean and standard deviation of treatment, cost, and the length of stay. So 2 descriptive statistics table we are going to get. 2 descriptive. I think Mr. Mansoori, he's somewhere in the market. Okay, leave. So 2 different type of descriptive statistics tables we are going to get. The first one is for the cost. I'll remove the candidate. The first one is the cost, and second one we are going to get for the length of stay, because 2 independent variable we have added in the test. This is the table, descriptive statistics for the cost, and second table we are going to get for the length of stay. Clear? And this is the mean and this is the standard deviation. Yesterday, I think day before yesterday, I have shown one table to you. In that table, what I have shown, that whenever we are having a 2 independent variable like cost and length of stay, so we don't have to add 2 different tables in the thesis. We can club both the tables. What it means, you can see that type of bone and type of material used for the treatment, column number 2 and column number 3 is the similar in both the tables. You can see here in this table also, column number 2 and column number 3 is the same. Just here I have written cost, and at the bottom you can make length of stay, and you can continue with the table because everything will remain same. Or what you can do, you can delete this column. You have to delete this column, and you have to make 2 more columns. For example, on the top you are going to,
I didn't get that. Could you try again?
on the top you can write here cost, that this is the mean and SD of the cost, and like these similar 3 columns you have to make further on this side, and on the top of those 3 columns you have to write length of stay, and again you can write mean, SD and N, and these will remain same. So no need to add at bottom. So you will having 2 different options. So out of these 2, which one is more recommended, I will suggest this one, that write cost and LOS on the top, and then make 3 different columns here at the site. One is for mean, one is for mean and SD, and last one is for the N, like here it has already mentioned. And data of these 3 columns should be added on the data of these 3 columns. This should be added on the column which you have made at the previous table. So like you don't have to add 2 different tables in data of both length of stay as well as the cost. You can show at the single table only. Now we'll see what we have got. This first table is showing the number and coding. These are the coding, and these are the number of patients which are falling under each category. And I'm going to ignore the total at the bottom. We'll see what we have. We'll try to find lowest and highest. I have already marked red color. This is the lowest and this is the highest, and it is the cost. That minimum cost was found in 12 patients, those who were treated with biomaterial and having a fracture of tibia, whereas the highest cost were observed in 13 patients, was found to be 1405, where patient was treated with autograft and they're also having a fracture of tibia. So you can see that minimum cost was also observed in tibia, and maximum cost was also observed in patient having a fracture of tibia. But type of treatment given, in highest cost it was found to be autograft, and in lowest cost it was found biomaterial. So you can say that if you want to treat tibia, fracture of tibia, then biomaterial will be the better alternative if you want to reduce the cost, and autograph will become the costlier treatment. We'll see length of stay. This is the descriptive statistics, and I have already marked the lowest and highest. Lowest was observed here 7.9, and highest was observed 10.9. And you can see what lowest length of stay was observed for a patient who is treated with autograft and having a fracture of humerus, whereas the highest length of stay was observed where autograft was the material and fracture was occurred in the bone called femur. So you can say that humerus is the bone which will take less time to heal, whereas femur is the bone which will take the maximum time to heal. Length of stay in the hospital will be more. And previous table will show you that which material is cheaper and which material is costlier. So this is only descriptive statistics. You cannot conclude anything. What we want to find out this thing, that if I am treating any bone, for example tibia, instead of autograph, if I'll go to biomaterial, then how much length of stay is going to reduce, or how much cost it is going to affect it, something like this. So that will be taken from the further tables. Next table you are going to get, that will be called a multivariate test results. Here the same thing, we have to see the p-values. Last we are not going to bother, we have to see the p-value, and you're going to see that most of the p-value were found significant. We are getting 0.000 or we are getting a 0.111, but all we don't have to refer, we have to see that where is our two independent variable. Our independent variable is site of fracture and the type of graft. And you can see here name of few scientists: Pillai, Wilkes, Hotlings, Roy's largest root. That means test has been applied with the help of 4 or 5 different scientist equations, that equation which was running behind the test. So here what you can do, most common significant value which will be written on the thesis for the Pillai and Wilkes, starting to these two, that but you have to quote on the thesis on the research paper that as per Pillai trace or as per Wilkes lambda, the significant value was found to be this much. So writing style for this result is like a ANOVA, like you are going to write a, see, you have to see that have you got the value of f or not. Wherever you have got the value of f, that means writing style will become the ANOVA only. Clear? So you have a degree of freedom, you have a value of f, you have a value and significant value. So it will be written like this: f is equal to degree of freedom, you are going to say Pillai was found to be 4, you are going to write 4, and last value which is given on the table, it will be for lowest largest root, that it will be used to bracket close value. For example, I'm writing for Pillai trace. So what I'll do, I'll just delete all these things, then I'll let you know how it will be written. It will be written like I write on the top. It is very visible on the screen. Yes, it's visible. F is equal to 4, 2 bracket close. Then I'll write this value 0.234, value of f. F was found to be 4.9 is equal to 4.975, p value was found to be Pillai trace this 0.001, like this we are going to write 0.001. Clear? Now it is showing what? This table. This p values is representing to you that site of fracture or graft, if they were used in different category, either they are going to affect the cost and length of stay or not. If these p value were found less than 0.05, it means yes, different categories of site of fracture. That means if the bone is different, obviously it is going to affect the cost and the length of stay. If these p value were more than 0.05, then you can say this particular, for example, here we have got 0.51 and here we have got 0.72. So in this case, I can say that site of fracture is not going to affect the cost and length of stay, but type of graft material is going to affect the cost and length of stay. But here we can say both are going to affect. Now, which one is going to affect more? Which is having a lowest p value? And lowest p value you can find that in Pillai trace and Wilkes lambda, I have got a point, this 1, 1. So I'll say graft is going to affect more as compared to site of fracture. Both are going to affect, but graft is going to affect more as compared to site of fracture. Next table will be test of between subject. This table indicates what? This table indicates that site of fracture is compared with both two, cost and length of stay, as well as graft is compared with cost and length of stay separately. It is possible that when we are talking about site of fracture, so might be it is going to affect cost, but it is not going to affect length of stay. Or when we are talking about graft, it is going to affect length of stay, but it is not going to affect cost. So this we are trying to find out, that each type of independent variable with both type of dependent variable. Previous table will give you about overall this multivariate test. but here you are going to get exact, and you can find that different results we have got. It is interesting. This 4 p-value we have to find. First we have to find that where are our two independent variable, and here we have site of fracture and graft, and we'll see what was the p-value. And here you can see the first p-value is more than 0.05, so this is not going to affect. Second p, remaining all the 3 p-value are going to affect because all are less than 0.05. These three all are, and least value is here, this one, this p-value, least one, this one is the least one. I'll mark as a star, let star here. Clear? Now you can see cost is not going to be affected when we are talking about site of fracture, because p-value was found more than 0.05. But length of stay is going to affect when we are talking about only site of fracture. And when we are talking about graft, that what type of graft we have used, cost is also going to affect, as well as the length of stay also going to affect. But out of these two, which more? We'll say cost is going to affect more, because the p-value of the cost is less as compared to the p-value of length of stay. P-value of length of stay is 0.12, and p-value for the graft comparing cost was found to be 0.000. So we'll say this affect more as compared to this one, but this is not going to affect. That means cost will be not affected by the site of fracture. So like this we have to compare. And the last one is the parameter estimate. This will let you know that if you switch the treatment, for example, if you are having you're treating the patient with autograft biomaterial, and you will switch to autograft, then how much it is going to affect the cost and how much it is going to affect the length of stay. So how it will be calculated, or how the result will be computed, the same rule, last category will remain as a standard. It means what? It means here you can see on the first table, now we have a 3 category under both. So this femur will act as a standard, and here biomaterial will act as a standard. So data of femur and data of biomaterial we are not going to get. So femur will be compared with tibia, and femur will be compared with the humerus. Biomaterial will be compared with biomaterial along with platelets, and biomaterial is compared with the autograft. Like this comparison we are going to get. So how it will be? See, codes will be written. That's why the first table will be given by the software, because we are not getting here names, we are getting a codes. We are getting codes. So codes we have to refer. So you can see first table is divided into half, because two dependent variable was there. One was cost and second was length of stay. So data which we have got, this data belongs to cost, and lower one belongs to this one belongs to length of stay. This is data of length of stay, this is the data of the cost, it means. So we'll see what we have got. We'll see first p-value, that which case we have got the p-value. So obviously where we will get the p-value, that means it is going to affect, and wherever p-value is more than 0.05, I will say it is not going to affect. The test was found not statistically significant. Now you can see when comparing cost, site of fracture 2 was co2 was femur, and this was tibia, this was humerus, and this was femur F. So if the patient is having fracture of femur and you can't say that this is actually meaningless, that instead of the person is having a fracture of humerus. So it is meaningless, but it's statistically, obviously, we have to find out that what it means, what type of data we have got. So if the patient is having everything remains same, but that patient was not having the fracture of femur, instead of that the patient is having a fracture of humerus, then cost is going to increase $22. But if patient having fracture of femur, instead of that the same patient were having a fracture of tibia, then cost is going to reduce $69. This you can find out with beta. Clear? And the same time, three type of graft we will use: autograft, biomaterial with platelets, and biomaterial only. So instead of biomaterial, if you are using a biomaterial plus platelets, the cost is going to increase $130. And instead of if biomaterial, if you treat the patient with a autograft, the cost is going to increase $307. That is the meaning. Now, if we'll see length of stay, the same method, last will become reference. And if you'll say fracture of femur, if person is having a fracture of humerus, then he have to or she have to spend 1 day less in the hospital, 1.1 day. And person is having a fracture of tibia instead of femur, then he have to spend minus 1.15 days. Here you can see we have got a all negative result. That means whatever the last category is there, instead of that we patient have to spend less number of days. Here also we have got a negative. So wherever we have got a negative result, it means it is going to reduce. Either it is your length of stay or it is your cost. Or if you have got a result on positive, so it means the cost is going to reduce, increase. Or for example, here we have got positive, and these two value we have got positive. So we'll say the cost has been increased or length of stay has been increased. And wherever we have got a negative value like this, -69, so we have to say that the cost has been reduced this much of dollar. Either it is your dollar or INR, whatever you can quote. So these should be taken, whatever the things I have marked in a box, that should be quoted in the research paper or in the thesis. This one, and this one. So this is the material, and even you can find the contrast results, but this table will be too long. That means here you are going to see only two category: level 2 versus level 1, level 3 versus level 1. Like this you are going to get a more than 15 or 20 labels, because what has happened, for example, if you have a 6 different categories, for example, here 3 under site of fracture and 3 under type of graft. So 3 into 3, 6. So 6 category we are having actually. So what I used to write, for example, like this. Just wait, what has happened? Yeah, that we have a, B, and C, which is designated to site of fracture, and 1, 2, and 3, which is designated to type of graft. So we have a set called A1, then A2, then A3, like this. Then we have a set of B1, B2, and B3. Then we have a set of C1, C2, and C3. The total, it will be 9. So 9 labels you are going to get like this. I have taken a screenshot only one, like this: level 2, level 1. First, you are going to get a picture of level 1, then level 1 with level 2, then level 1 with level 3, like this. 9 matrix result you are going to get, and there you can find that how much cost is going to affect or how much length of stay is going to affect. Like this I have got here in 2 different tables, where I have got a interesting result that I have copied, remaining I have not copied. So in this table, you can find label 2 was biomaterial with platelets. That was code number 1. Was compared with autograft of another variable. So the analysis shows that, like this, you have to write the results. The analysis shows that the cost was significantly lower by $177, but at the same time, length of stay in the hospital is going to increase 9 days. What you have to do, you have to find those results where one side you are getting negative value and one side you are getting a positive value, like this. That means two independent variable we are having. So you both side you cannot stay that cost is also increasing and length of stay is also increasing. We have to find a opposite results. That means what? One side, the aim of the where the patient is going to be benefited. Patient is going to be benefited when he has to spend less number of days in the hospital, as well as the treatment will be cheaper. So cost will be reduced when we are going to get a negative value, and length of stay also we are going to get when we get a negative value here, both sides. So both negative results, wherever in which labels you have got, that should be added in the thesis. If not, if you're not getting a both negative subsets, then what you can do, you can go for these also, where you have one side negative, one side positive. That also can be taken, but best will be called where you have both negative, like this. But if we don't have, no problem, we'll take a negative or a set of negative and plus, like this we'll take. Otherwise, what we are looking for, negative negative. See, this decision will be taken based upon the type of research. We have to see that where the population is going to be benefited. For example, if it is this test will be run for the management students, where you are discussing about sale of the company, and you want to find out the factor that which are affecting sale, how the sale can be increased. So obviously you are going to find those factor where both side positive will be there. So you have to see that where the patient is going to benefit it. So those subset can be discussed in the result. Here you can see I have discussed a negative positive results. That one side I'm showing that cost can be reduced by $177 if you are using a biomaterial as compared to autograft. But same time, you have to spend around 1 day more. You have to spend less money on the treatment, but you have to stay 1 more day in the hospital. Clear? On the second result, you can see biomaterial only further lower the cost by $308, but also increase the length of stay 1 day, near about 1 day. So it says what? That if you want to spend less money, you have to stay more in the hospital by choosing this type of treatment. So this was the last, and what the difference I have already told. I have not added the age as a covariate. So once you will take a numeric variable as a covariate and you will add here this slide here, age here, this age here, the test will be called MANCOVA. And if you are not adding age, the test is Manova. That's the difference. And how you are going to get your result with here in the here you have got the site of fracture and graft, and along with that you are going to get the result of age at the bottom. And in this table also, here you have got only two values, and third value, one more column will be made here, and one more p value you are going to get here, that is for the age. Directly age is going to affect cost or length of stay. So two p value will be there. One is for the cost and one is for the length of stay, and directly you can compute that what it means. So you have to refer 6 value instead of 4. That is the difference. So these are the most advanced tests where you can add something from your side into your thesis. Now, if any one of you are having a doubt that I'm working on so and so, and either this particular test is applicable to my thesis or not, so what you have to do, refer these signs whenever you are referring the presentation, that to dependent variable you can add only numeric variables. To fixed factor, which are called independent variable, you can add only category, and this test will be called Manova. Clear? And if you'll add age here, then it will be called MANCOVA. So this picture of multivariate have to refer to find out that type of variable which you have made for your study, you can add it or not, and see how many I have added. If I'll add one more here, still it will be remain as Manova. If I'll add one more numeric variable here, still the test will remain Manova until unless I'll not add numeric variable here. If I'll add numeric, then it will turn to MANCOVA. Like there's a difference of ANCOVA and ANOVA that is there. So any doubt in these statistical tests, please let me know. I'll happy to take the queries, and we can still discuss further. And this was the end of this presentation where all the statistical test ends. That means we have covered near about 13 or 14 statistical tests from the beginning. I just named them out. We have done first test called student t-test, then independent t-test, then we have done paired sample, then we had done ANOVA. These four were parametric. Then under non-parametric, we have done chi-square with two types, goodness of fit and test for independence, Mann-Whitney U and Kruskal-Wallis, based upon one sample, two sample, or more than two sample. The alternative of ANOVA is Kruskal-Wallis. The alternative of Mann-Whitney U is independent t-test. After that, we have come to more advanced test, that 2 ANOVA, ANCOVA, linear regression, correlation, linear regression through GLM, and under the GLM, these four tests was there: ANCOVA, Manova, and MANCOVA. So I'll just take the queries. If not, and in tomorrow's session, I'm going to take a session on sample size, that how the sample size will be calculated for the further study. And the same time, I'll discuss a few things on hypothesis and type of error in the research. So with these, I think 2 days classes, our most of the topics will be covered. After that, we will have a test, and I will let you know that on which day we are going to keep the test, what will be the mode, how many questions will be there. That will be informed through WhatsApp group to all the participants. Yes, please. Any queries, you can write on the chat box. I'll happy to take. Any doubt in the statistical test? I'm not talking about which we have covered so far today. So far we have covered. You can ask from that also. Which one I have named just now? From any. I'll just stop the recording.